Hello students, once again welcome you to GK's maths classes. Today what we are going to do is we are going to start with a new topic called applications of differentiation, where under application of differentiation there are various subdivisions like you have rate of change, you have increasing and decreasing function, then you have maxima minima. It's a very important topic. Now that we have finished differentiation, we are going to go for applications of differentiation. So today I'm going to introduce you to increasing and decreasing function introduction, and we will also try to solve few problems. Okay, so let us begin with the problem, with the topics. Okay, so what is an increasing function? So first let's discuss what an increasing function is. Okay, increasing function. And there's a word called strictly increasing also. We'll come to that later. Okay, now, so first is y equal to f of x is a function. Y equal to f of x is a function, and you know every function graphically represents a curve. Every function graphically it represents a curve. We know this. Okay, and there are two variables. What are the two variables? X and y are the two variables. And what type of variable is x? X is an independent variable and y is a dependent variable. X is an independent variable, y is a dependent variable. Okay, that is very clear. Now, when do I say a function is increasing? Or when do I say a function is strictly increasing? Okay. Now here I said x and y are variables, right? That means when x increases, y also increases. Or I can say when x decreases, y also decreases. Okay, this is one way of defining an increasing and decreasing function. The increase in x corresponds to increase in y, or you can say decrease in x corresponds to decrease in y, or you can say x and y are directly proportional to each other. Okay, so the increase in x corresponds to increase in y, not necessarily linear. Just for our understanding, I've written y proportional to x. It can be y proportional to anything. I mean, idea is the increase in x corresponds to increase in y. Okay, that is why I said they are proportional to each other. They are not inversely proportional, but they are directly proportional to each other. Okay, so this is one way of understanding what an increasing function is. The second definition for me is, how do I look at an increasing function graphically? Okay, so I'm going to draw three different types of graph. So one graph is going to be like this, the other graph is going to be like this, and the third one I will try to draw like this. Okay, I have drawn three different types of graph. So this is how an increasing function graph will look like. Now you can analyze for yourself. For different values of x, when x is increasing, you can see when x is increasing, y also increases. So increase in x corresponds to increase in y. Can you see that? So the increasing function graph will always be like this. Same case here also. I'm sorry, here I drew a wrong graph. Okay, this is wrong. Instead of drawing like this, I drew like that. It can also be like this. That means increase in x corresponds to increase in y. You see, increase in x corresponds to increase in y. Now, look at this graph. Here also increase in x corresponds to increase in y. Can you see it? Increase in x corresponds to increase in y. So graphically, this is how an increasing function looks like. Okay. Now what is the difference between these curves? Well, I will categorize the first and second as strictly increasing, whereas I categorize the third one as increasing. Okay, it's like saying, for example, you see, for example, look at these numbers: 1, 2, 5, 9, 11, 15, 20. This is strictly increasing. Okay, just giving an example. Suppose if I have 1, 2, 5, 5, 9, 9, 9, then 11, 15, 15, 15, 15, 15, 20. This is also increasing, but you see, at some places it takes the same value. You see here, for two different values of x, I have, for two different values of x, I will have the same value. For different values of x, I get the same value. Correct? So dy by dx is going to be 0 there. Okay, dy by dx slope will be 0. So when you have a graph like this, see here no values are repeated. For different x value, I have different y values. For different x values, I have different y values. Okay, so this is strictly increasing, whereas this is only increasing because for the increase in x, it is not that y is decreasing, but y takes the same value. It doesn't change. Okay, I hope you understand what is the difference between an increasing function and strictly increasing function is. Okay. So that's one representation using graph. Now third way is, for example, if I take two neighboring points, say x1 and x2, let us assume that this is x1 and this is x2. Now clearly you can see x1 is strictly less than x2. If f of x1 is less than f of x, if x1 is less than x2, this is my f of x1 and this is my f of x2. This is f of x2, this is f of x1. So clearly, for an increasing function, f of x1 will also be less than f of x2. This is the case for strictly increasing function. Whereas if you look at this situation, for x1 less than x2, f of x1 can be less than or equal to f of x2. There are cases where for x1 less than x2, you can have f of x1 equal to f of x2. So when you have this equal to sign, you call this function as strictly increasing. Sorry, call this function as, just say, increasing. So when the graph does not stagnate, it keeps increasing, you call it increasing function. When the graph is increasing but it stagnates at some point, you call it just increasing. Otherwise you call it strictly increasing. I hope you see the difference between an increasing function and a strictly increasing function. I have given you both the definitions. Okay, so you can look at an increasing function in three different ways. One is when x increases, y increases, or when x decreases, y decreases. Both are exactly the same. Y is proportional to x. The second situation is, how do I visualize an increasing function? Visualization of increasing function can be like this. The graph can be like this, or it can be like this, or it can be like this. In the first and second case, it is strictly increasing because the values are not repeated for y. For different x value, y is different. Whereas in the third diagram, even though when x increases, y also increases, for some x1 and x2, y remains the same. So it is increasing, but it is not strictly increasing. Now the third one is the same thing. I am writing it algebraically. If x1 is less than x2, f of x1 will be less than f of x2 if it is strictly increasing. That is the situation for these two. But when x1 is less than x2, f of x1 is less than or equal to f of x2, you call it increasing. Now the last one, which is the most important, okay, because this is applications of differentiation, I have to bring in calculus, correct? Now how do I bring in calculus? Now what is the geometric meaning of dy by dx? The geometric meaning of dy by dx is slope of tangent to the curve, correct? Slope of tangent to the curve. Now what do? You choose any point on the curve. I choose any point on the curve and I draw a tangent. You say I am drawing a tangent. Let me draw the tangent. You look at this tangent. This tangent will always make an acute angle. Okay? You move wherever you want. You move the point wherever you want. This tangent will always be an acute angle. When it is an acute angle, theta is less than 90. Slope, tan theta will always be positive. Tan theta corresponds to slope. Dy by dx also corresponds to slope. Therefore, for a increasing function, for a strictly increasing function, dy by dx will always be positive. Why it is always positive? Because the tangent drawn to the increasing function will always make an acute angle with the positive direction of x-axis. Since the tangent makes an acute angle, its slope has to be positive. Okay. Now, whereas if it is an increasing function, you can say dy by dx has to be positive, but it can also be 0. In these situations, dy by dx will be 0. What is the dy by dx? Change in y with respect to x. So when there is no change in y, dy by dx is going to be 0, right? No change means 0. So for an increasing function, dy by dx can be greater than or equal to 0. For strictly increasing function, dy by dx is greater than 0. Okay? So this is how you have to understand increasing and decreasing function. This is all about increasing function. Everything that you require for an increasing function, I have written here. One is when x increases, y increases. How do I represent it graphically? Okay, how do I represent it algebraically? And how do I represent it using calculus? Okay, so dy by dx corresponds to slope. If the slope is positive, when will the slope be positive? If I draw a tangent and the tangent makes an acute angle. That is possible only when the curve is increasing. Is it clear? Now let's go to the next one. The next part is decreasing function. So what is a decreasing function? The first definition. When x increases, what happens to y? Y decreases. Right? When x increases, y decreases. Or you can say when x decreases, y increases. In other words, you can say x and y are inversely proportional to each other. Whereas in increasing function, x and y are directly proportional to each other. Just to make you understand, I'm using the word proportional. Okay. Now here y is inversely proportional to x. So increase in x corresponds to decrease in y. Decrease in x corresponds to increase in y. In either case, it is a decreasing function. Now as usual, I need to represent a decreasing function graphically. Now how do I represent it graphically? A decreasing function will always look like this. It can be like this, or it will decrease, stagnate for some time, and then decreases. Okay, so the diagram 1 and diagram 2 is strictly decreasing, whereas this is just decreasing. Okay, now what's the third part of it? If I choose two neighboring points, say x1 and x2. And you can notice very carefully, see when x increases, the y is going to decrease. Okay? So when x1 is strictly less than x2, f of x1 will be definitely greater than f of x2. Okay? This is a case for what? Strictly decreasing function. Similarly, if x1 is less than x2, in this case, x1 is less than x2, you can say f of x1 will be less than, or it can also be, will be greater than or equal to f of x2. It can be greater or it can be equal to. Okay, so this is the case for decreasing function. Now what's the last way? Last way I want to talk about it using tangent. So let us choose a point on the curve and let me draw a tangent. And the tangent, so this is the tangent. What angle this tangent makes? This tangent makes an obtuse angle. Since it makes an obtuse angle, its slope, what is slope? Dy by dx will always be less than 0 if it is strictly increasing, strictly decreasing, or dy by dx will be less than or equal to 0 if it is decreasing. Okay, now I hope you have understood what a increasing function is, okay, and what a decreasing function is, and how it looks graphically, and how you can understand it algebraically, and how you can understand it using calculus. I hope you also know why for an increasing function dy by dx must be positive, because the tangent makes only acute angle. And you also know that why dy by dx is less than 0, because you know very well that the slope makes obtuse angle, the tangent makes an obtuse angle. Okay. Now, is it necessary that every increasing function should be followed by a decreasing function? Not necessary. Okay. So we'll come to those things when we are doing problems. Now, how do I solve the problem? I'll just give you a rough method of solving a problem. Okay. It may be useful for you to solve questions. Now, what is the method of solving problems? Now, what is the method? First method is, first you find, suppose you have a function y equal to f of x, find dy by dx and simplify. So you need to simplify dy by dx if it is possible for you to simplify. Okay. So first you find dy by dx and simplify. Second is, you take dy by dx as 0. You find dy by dx as 0. When I put dy by dx is equal to 0, for example, if I have a curve like this, suppose I have a curve like this, from A to B, it looks like an increasing function, correct? See, look at this, from A to B, it looks like an increasing function, am I right? A to B is increasing. When it is increasing, definitely here my dy by dx is positive, correct? Now from B to C, when I go from B to C, when I come from B to C, we can see clearly it looks like a decreasing function. It is a decreasing function, correct? So your dy by dx is going to be less than 0. Here the tangent makes acute angle. Here the tangent makes an obtuse angle. So when you move from A to C, your tangent, which is making an acute angle, will slowly turn and it will become an obtuse angle. It will become 0. So you are finding the point You are finding this point where dy by dx is going to be 0. In mathematical language, it is also called the critical point, otherwise called the turning point, because that is where the curve takes a turn from increasing to decreasing or from decreasing to increasing. Okay, so it depends on how the graph is. So dy by dx equal to 0 is a must, because that is where you split the function as decreasing and increasing or increasing and decreasing. So it is a must to find dy by dx equal to 0. So why you are finding dy by dx equal to 0? That is a point where the tangent is parallel to x-axis, or you can say that is a point of, it's called the critical point, where the interval is going to be divided into decreasing function and increasing function. Okay, you see, to the left side of b it is increasing, to the right side of b it is decreasing. At b the tangent is parallel to x-axis, because dy by dx is 0. So you are finding dy by dx is equal to 0 just to split left side of b and right side of b, to understand to the left side of b whether it is increasing or decreasing, to the right side of b whether it is increasing or decreasing, based on whether my dy by dx is going to be positive or negative. In this case it is positive to negative, and at b dy by dx is 0. So when I am saying dy by dx is equal to 0, I am finding such points b, okay, where the curve takes a turn, or otherwise called the critical points. Okay, so dy by dx equal to 0 and find the x value. You see, for b there will be a corresponding x value, right? I am finding such values. Okay, or suppose if I have the graph like this. Okay, for example, this is at 1, say this is at 3. Okay, so when I move from a to c, when I move from a to d, okay, when I move from a to d, I pass through this point where dy by dx is 0. Again I pass through this point where dy by dx is 0. Okay, at these points dy by dx is 0. Why? Because the tangent is parallel to x-axis. Correct? Now to the left, let me call this as c and say b. Okay, let me call it as c and b. To the left side of c it is increasing, to the right side of c it is decreasing. Again to the left side of b it is decreasing, to the right side of b it is increasing. So dy by dx equal to 0, when I put it as dy by dx is equal to 0, in this case I will get x as 1 or 3. What is this 1 or 3? Are the critical points, or you can say are the points where the dy by dx changes from positive to negative or from negative to positive, or you can say it is a point where the tangent is parallel to x-axis. It is neither positive nor negative. If it is positive, it is increasing. If it is negative, it is decreasing. But when dy by dx is 0, it is neither positive nor negative, or it is a point where the tangent is parallel to x-axis, or the curve takes a turn from increasing to decreasing or from decreasing to increasing. Okay. So first I find x. What's the third one? Using x values found, okay, using this x values that is found, split the intervals. If you don't understand, don't bother. While doing problems, I'll tell you. Split the intervals. Now, fourth point is, check if dy by dx is positive or negative in these intervals. Now finally, if dy by dx is positive, you say the function is strictly increasing. If dy by dx is negative, you say the function is strictly decreasing. With the problem, okay? So first you write y equal to 2x cube minus 9x square plus 12x plus 15. Now what is our first step? First step is I want to find dy by dx. So what is dy by dx? It is 6x square minus 18x plus 12. But in the first step I also said simplify if possible, right? So I'm going to simplify. Now how do I simplify? I simplify by taking 6 common. So I get x square minus 3x plus 2, which can be factorized as x minus 1 into x minus 2. Just a normal quadratic equation. So I am done with the first step. What is my first step? Differentiate and simplify if possible. And it was possible, so I simplified. Now what is my second step? My second step is to find the critical point. So I am going to find dy by dx equal to 0. Okay, dy by dx equal to 0. When I put dy by dx is equal to 0, I get x is equal to 1 and I get x is equal to 2. Okay, that is my second step. You see, put dy by dx is equal to 0 and find x. Now what is the third step? Using this x, split the interval. Now how do I split the interval? Draw the number line. This is 1. There are different people use different techniques. I like this method, so I am following this. I write it as 1 and 2. Okay, write it in proper order. Now the intervals are, third step, the intervals are, to the left side of 1 it is minus infinity to 1. Make sure you write open interval. Okay, don't write closed interval. If you put closed interval, then dy by dx, we'll talk about it later. Then it is 1 comma 2, minus infinity comma 1, 1 comma 2, and then 2 comma infinity. So this is how you split the interval. You see, minus infinity to 2, 1 to 2, 2 to infinity. Correct? So I am done with the third step. Now I need to check if dy by dx is positive or negative in these intervals. Now how do I do it? First let's take the first interval. I'll take minus infinity comma 1 and choose dy by dx before equating to 0. Okay, that will be easy for you to simplify, which is 6 into x minus 1 into x minus 2. Now how do I check? Choose any number in between minus infinity and 1, any number. Okay. For me 0, so I'll choose 0. So what do you say? Dy by dx is, wherever x is there, put 0. 6 into, what is 0 minus 1? Negative. No need to calculate, you just say negative. What is 0 minus 2? Negative. What is negative into negative? Is positive. So if dy by dx is positive, what do you say? The function is strictly increasing in minus infinity comma 1. If you put a closed interval, then you can choose 1. In that case, dy by dx will be greater than or equal to 0. Then you can say it is increasing. You don't need to say strictly increasing. Okay. Now choose a number 1 comma 2. Choose the interval 1 comma 2. And what number will you choose in between? Some number you can choose. Say I will choose 1.5. Substitute in dy by dx. What do I get? 6 into, what is 1.5 minus 1? Positive. No need to calculate. What is 1.5 minus 2? It's negative. Positive into negative will be less than 0. Therefore, the function is strictly decreasing. Where it is strictly decreasing? In 1 comma 2. Now the third interval. What's the third interval? 2 comma infinity. 2 comma infinity. Choose a number here. I'll choose 3. What is dy by dx? Dy by dx will be 6 into, what is 3 minus 1? Positive. What is 3 minus 2? Positive. Therefore, I can say the function is strictly increasing in 2 comma infinity. That's it. Now, I forgot to write one more step. You can write the conclusion. It's very important you write the conclusion. Now what is the conclusion? You can say the function is strictly increasing where in minus infinity comma 1 union 2 comma infinity. Minus infinity comma 1 union 2 comma infinity. And the function is strictly decreasing where in 1 comma 2. So this will be the complete solution for this particular problem. Okay, now let me do it on GeoGebra. So what is the function, whether what we have done is correct or not? Here y equal to 2x cube and then minus 9x square plus 12x plus 15. Look at the graph. Such a lovely graph. You can see, I'll just bring this down. You see here, you can see the function increases from minus infinity to a particular point. Remember, this is 5, so this will be 1, this will be 1, so it is increasing from minus infinity to 1. Okay, this is actually 1 comma 20. You see, this point is 1 comma 20. Okay, so it is increasing from minus infinity, it is increasing from minus infinity to 1, and then you see from 1 to 2, see this is 0.2, this is 2 comma, I don't know what the y value is. At 2, from 1 to 2 it is decreasing. Can you see? The curve is down, and then from 2 to infinity it is increasing. Okay, that's very, very important observation. I will show you using the tangent also, so that you know what I'm doing. I'll choose a point anywhere you want, then I draw a tangent. Okay, just to keep looking at the tangents, I'm finding the slope of this tangent. Look at the tangent values. Tangent value is positive. See, 12, it's positive. Now I keep moving this value, I keep moving a. You see, when I keep moving a, I think something is wrong. 1 second. One second, just to redo it. Maybe I made a mistake here. I choose a point and I draw a tangent, then I find the slope. So you have slope as positive. Okay, now look at I'm moving this point. You see, slope is always positive. Slope is positive. Also keep an eye on the point A. It's always positive. When it reaches this particular point, you see, when it reaches this point, at 1 comma 20, dy by dx is 0. So minus infinity to 1, it is increasing. Now you see, slope is also 0. That's a turning point. Now I keep coming down. So when I move, it becomes negative. So dy by dx is negative. The function is decreasing. See, the tangent is making an obtuse angle. So when I keep moving down, you reach a particular point here. Sometimes it's difficult. Okay, you can understand that. Okay. It has to be 0, but some, because of scale, there will be some error. When a becomes 2, so when a becomes 2, it will become 0. And you can visualize it. Okay, now it comes. You see, when a is 2 comma 19, it is 0. Then again from 2 to infinity, it becomes positive. So from minus infinity, you can see once again, from minus infinity to 1, it's increasing. 1 to 2, it is decreasing. And then from 2 to infinity, it is again increasing. Okay, I hope that is clear to you. Okay, let's go to the next question. This is a slightly different question from the previous one, because here you're going to have minus 2x cubed. So let's see how to do it. y equal to minus 2x cube plus 3x square plus 12x plus 6. What I should do? Differentiate dy by dx. What is dy by dx? Minus 6x square plus 6x plus 12. I just differentiate it, nothing else. Then what I do, I need to simplify. How do I simplify? Take minus 6 out. What do you get? X square minus x minus 3. Sorry, minus 2. Is it possible to factorize this? So this will be x minus 2 into x plus 1. Just factorizing the quadratic. This is my dy by dx. Step 1 is completed. Now what is step 2? Turning point, right? So put dy by dx as 0. So when I put dy by dx as 0, what are the x values? I will get x is minus 1 and I will get x is 2. So these are the critical points. Now what I do, I split the interval. How do I split the interval? Minus 1, this is 2. So the intervals are minus infinity comma minus 1, minus 1 comma 2, and then 2 to infinity. I split the interval. Now what do you do? Choose the first interval. Minus infinity comma minus 1. Before that, let me write where I am going to substitute. I will substitute here. Minus 6 into x plus 1 into x minus 2. Now choose a number between minus infinity and minus 1. The number that I choose between minus infinity and minus 1 will be, say, minus 2. So what is my dy by dx? My dy by dx will be, already there's a minus 6. Minus 2 plus 1 will be negative. Minus 2 will also be negative. So negative into negative into negative will be less than 0. Therefore, the function is strictly decreasing where? In minus infinity comma minus 1. It is strictly decreasing in minus infinity comma minus 1. Now what do you do? Choose a number between minus 1 and 2. What number will I choose? Obviously 0, because it's easy to calculate. So dy by dx will be minus 6 into, when I put 0, I get positive. When I put 0, I get negative. So this is obviously positive because minus into minus is positive. Therefore, the function is strictly increasing where? In minus 1 comma 2. Correct? Now choose a number between 2 and infinity. I will choose 3. dy by dx will be minus 6 into, I am substituting 3 here. 3 plus 1 is positive and 3 minus 2 is positive. Negative, positive, positive will be less than 0. Therefore, the function is strictly decreasing in 2 comma infinity. So now what is my conclusion? My conclusion will be the function is strictly decreasing in minus infinity comma minus 1 union 2 comma infinity, and it is strictly increasing where? In minus 1 comma 2. Is it clear? Y equal to minus 2x cube, okay, plus 3x square plus 12x plus 6. So I got a graph here. Okay, see, the curve takes a turn at minus 1 and it also takes a turn at, somewhere, I think it's very huge, so it also takes a turn at 1. Okay, can you see that? So it has a lower value and an upper value. Okay, we'll come to that later. Now what do you do? I'll take a point on the curve as usual. I'll just show you for 1 or 2 sums, then we need not do for all problems. Tangent and I will find the slope. So you can see clearly the slope is negative. Where is it negative? From minus infinity. See, I am coming from minus infinity. See, this is minus infinity, right? From minus infinity onwards, when I keep moving, my dy by dx is negative. When I reach this particular point, you see the tangent takes a turn and dy by dx is 0. Where is dy by dx 0? At x is equal to minus 1. This is what you also got, right? Okay. Now what do? Keep moving. When you move away from minus 1, you see your tangent changes from negative to positive now. Now it is increasing. Where it is increasing, you keep moving up. Okay. When you reach this particular point, you see, let me see whether I can change it directly. Okay. So when I reach this particular point, you see I'm moving this point. When you reach this particular point, dy by dx will be 0. Since the scale is very small, okay, you are not able to see it, but otherwise it's understood. It's very, very close to 0. I think you can visualize it. So, and then it starts decreasing. And then you see, after that it is again negative. So minus infinity to minus 1 it is decreasing, 1 to 2 it is increasing, and then 2 to infinity it is again decreasing. Okay, I hope that is clear to you. We'll try one more question. This is a 4th degree equation. We have solved the previous 2 problems were of degree 3. This is a 4th degree equation. So let's see how complicated it gets. And the power increases. So y equal to x power 4 minus 8x cube plus 22x square minus 24x plus 21. Correct? Now what do? Take dy by dx as 0. First you find dy by dx. What is dy by dx? 4x cube minus 24x square plus 44x minus 24. Now I need to simplify. How do I simplify? Only way is take 4 outside. So you get x cube minus 6x square plus 11x minus 6. Correct? Now you can see clearly when I add all the coefficients, they add up to 0. 1 minus 6, 11 minus 6. If you add them, it becomes 0. I think you know that when if it adds up to 0, x is equal to 1 is a factor. Or otherwise, you take x is equal to 1 and substitute quadratic equation by trial and error method. When you put x is equal to 1, you get 0. That means 1 is a root. How do I find the remaining root? You can do polynomial division or you can do synthetic division. So I prefer to do synthetic division. So let me explain once again what synthetic division is. What is coefficient of x cube? It's 1. After that x square, it is minus 6. After that it is x, which is 11. After x it is constant, so it is minus 6. Okay. Start with 1. Outside you add, inside, outside you multiply, inside you add. Okay. Start with 0. 1 plus 0 is 1. 1 into 1 is 1. Again add. It's minus 5. Then you multiply. You get minus 5. Add. It is 6. Again multiply. 1 into 6 is 6. Add. It should become 0. If it doesn't become 0, then 1 is not a factor. Okay. Now that you have done, how do I write it? This is 4 into this 4. And 1 is a factor, so I'll write x minus 1. If x is equal to 1 is a root, x minus 1 is a factor. And remaining factors. This is the highest degree is 3. So when I do polynomial degree with x, when I do polynomial division with power 1, okay, I will definitely get the quotient of power less than 3. So less than 3 means maybe it starts from 2. So x square minus 5x plus 6. X square minus 5x plus 6. Because this is 3, 1 degree less you should write. So this is 4 into x minus 1. And this is a quadratic equation which can be factorized as x minus 2 into x minus 3. This is my dy by dx. What is my next step? I have to put dy by dx as 0 and find the critical point. So what are they? X is equal to 1, 2 and 3. So I differentiated and I simplified and I equated to 0. Here I got 3 critical points. Okay. Now what do? Split the interval. How do I split the interval? 1, 2 and 3. So the intervals are minus infinity comma 1, 1 comma 2, 2 comma 3, then finally 3 comma infinity. There are 24 intervals. You have a job. Okay. Now what do? First let's choose dy by dx where I am going to equate it to 0. So I got 4 into x minus 1 into x minus 2 into x minus 3. Now choose x is equal to 1. That is minus infinity comma 1. The best point obviously is 0. So what is dy by dx? Dy by dx will be 4 into 0 minus 1 is negative, 0 minus 2 is negative, 0 minus 3 is negative. Therefore this is less than 0. Therefore the function is strictly decreasing where in minus infinity comma 1. Then choose the second interval. What is the second interval? 1 comma 2. Choose 1.5. What is dy by dx? Same procedure. Is 4 into 1.5 minus 1 is positive, 1.5 minus 2 is negative, 1.5 minus 3 is also negative. So positive into negative will be positive, Therefore, the function is strictly increasing in 1 comma 2. Now go to the third interval. What's the third interval? 2 comma 3 and I choose 2.5 in between this. Now what is my dy by dx? My dy by dx will be 4 into 2.5 minus 1 will be positive, 2.5 minus 3 also will be positive, 2.5 minus 3 will be negative. So positive into negative will be negative. Therefore, the function is strictly decreasing in 2 comma 3. Now choose a number between 3 and infinity. Here you can choose 4 and I substitute in dy by dx. What do I get? 4 into positive. Therefore, the function is strictly increasing in 3 comma infinity. So what will be my conclusion? My conclusion will be the function is strictly decreasing where in minus infinity comma 1 union 2 comma 3 and the function is strictly increasing where in 1 comma 2 union 3 comma infinity. Okay, equal to x power 4, then minus 8x cube minus 8x cube followed by plus 22x square and then it is minus 24x plus 21. So I am done with the graph. So the graph is somewhere here. Let me pull this this down. Okay. So the graph is here. Okay. Now what I will do, choose a point. As usual, whatever we have done, choose a point. Choose a point on the curve. One second, just want to choose a point. And I will draw the tangent. I think something is wrong. Okay, let me try one more time. Else we'll just skip it. Choose a point on the curve. Okay, I got it now. Draw the tangent. I'll draw the slope. Now you can see clearly. Let me come here. You see? Below 1, okay? Below 1, that is minus infinity to 1. Minus infinity to 1 till you reach 1. Your dy by dx is negative. See, it's negative. Dy by dx is negative. So when you reach 1, you see, when you reach 1, because of the scale, I'm not able to show you exactly, but we'll zoom a little bit. Almost there, okay? It will be 0. It will be 0, and then from 1 to 2 it is increasing, and you got 0 there. You see here 2, and then from 2 to 3 again it will be 2 to 3, so very close to the scale error. 2 to 3 it will be decreasing, and then from 3 onwards it is increasing. So visually you can see, otherwise it's very difficult to imagine a graph of x power 4, it's very difficult. So this helps you to understand things better. I hope it's useful to you. Okay, now let's go to the next question. Now here I will do this problem. I have y equal to x plus 1 the whole cube into x minus 3 the whole cube. Now I want to find dy by dx. How do I find dy by dx? I am going to use product rule. What is product rule? X plus 1 the whole cube, 3 into x minus 3 the whole square, plus x minus 3 the whole cube into x plus 1 the whole square with a 3. I forgot to write that in front. When I differentiate that, I get 3 into x plus 1 whole square. I wrote in here. Now I need to simplify. I'll take 3 outside. I will take x minus 3 whole square also outside. X plus 1 whole square is also outside. And what do I get? I get x plus 1 plus x minus 3, which can be simplified as x minus 3 the whole square, x plus 1 the whole square, 2x minus 2. This is my dy by dx. I have differentiated and simplified. Now again I can take 2 outside, so it becomes 6 into x minus 3 the whole square into x plus 1 the whole square into x minus 1. There's a shorter way to do this problem. Usually what we do, usually we say dy by dx equal to 0. So I will get the x is equal to 3, I will get x is equal to minus 1, and I get x is equal to 1. Then you split the interval as minus infinity comma minus 1, minus 1 comma 1, 1 to 3, followed by 3 to infinity. You can do like this also. But if you observe very carefully, 6 is always positive. X minus 3 whole square is always positive. X plus 1 whole square will always be positive. So this dy by dx is going to be negative or positive, will be decided only by x minus 1. Correct? So can I say dy by dx will be greater than 0 only if x is greater than 1, when x minus 1 is positive. So x is greater than 1. So can I say the function is increasing in 1 comma infinity? I did not use the word strictly increasing, I used the word increasing. It is only increasing in 1 comma infinity. Okay. Now can I also say, I will remove this, this is not required for me, but I need to explain more in this. Can I say dy by dx will be less than 0 only if x minus 1 is less than 0, implies x is less than 1. X is less than 1 means what? The function is decreasing in 1 comma infinity. I purposely use the word increasing, I purposely use the word decreasing. Okay, why? Because when x is greater than 1, look at it. This is actually, when I equate it to 0, I'll get minus 1, I will get 1, and I will get 3. So when x is greater than 1, that is, when x is greater than 1, dy by dx, when x is greater than 1, my dy by dx will not be just greater than 0. It will be greater than or equal to 0, because when it takes the value 3, my dy by dx can be 0. So when dy by dx is greater than or equal to 0, it is not strictly increasing, it is only increasing. Okay. Now similarly, when I choose the value when x is less than 1, dy by dx is not less than 0, it has to be less than or equal to 0. Why? When it is less than or equal to 0, because when you choose minus 1, dy by dx is going to be 0. Okay, so it can't be strictly decreasing, it can only be decreasing. Okay, suppose if you want to find where it is strictly increasing or strictly decreasing, what you should write? You can say the function is strictly increasing in 1, here I made a mistake, it's actually minus infinity comma 1. Strictly increasing where in 1 comma infinity excluding 1 comma infinity excluding 3. Here your dy by dx will not be equal to 0, it will only be greater than 0. Correct? Similarly, you can say the function is strictly decreasing in minus infinity comma 1 excluding minus 1. Here you can say dy by dx will be strictly less than 0. You cannot write greater than 0 here, because when x is greater than 1, you are also including 3. At 3, dy by dx will be 0. If dy by dx is 0, you can say it is increasing or decreasing. You cannot say it is strictly increasing or strictly decreasing. I hope this is clear to you. If the question is asked for increasing, you can write this. If the question is asked to prove strictly decreasing, this is the answer you should write. I equal to, it is x plus 1 whole cube, x minus 3, right? Then it is x minus 3 the whole cube. Okay, great. It's a very beautiful graph. Look at this graph very carefully. Okay, let me go to home. I will choose a point on it and let us understand it. You see here, and I'll draw the tangent and I'll find the slope. What do you say about the slope? Slope is negative. Okay. And now I'm going to move the slope. So when I move the slope, look at the A value. When I come closer and closer and closer and closer and closer to what? Closer to -1. When I come closer to -1, I move from, look at this. When I come closer to -1, when I'm at -1, my dy by dx is 0. You see? So this is decreasing, dy by dx is 0, again decreasing. Okay? Again it is decreasing. So if you say -infinity to 1, it is decreasing, it's okay. But if you want to say strictly decreasing, you should say -infinity to -1, and then from -1 to 1. Okay, you have to break it. Okay. Let's see this point. I don't know where it is. See, the turning is here. Okay. How will I get it? Okay, now I got it. So now I bring this down. See, this negative, 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 negative reaches this particular point where dy by dx is 0. Well, it's very difficult for me to get it done because of the scale problem. So now you can see it changes from negative to positive. At one point tangent will be parallel to x-axis. Again it starts increasing. Okay. It starts increasing. It starts increasing. It's increasing. It reaches this particular point where dy by dx is 0. Okay, I think you can see it, right? So this is how you prove this problem. Okay, I hope this is clear to you. So it's from -infinity. It starts from -infinity. It comes to 1. It is decreasing. If you want to say strictly decreasing, you break it. -infinity to -1, -1 to 1. It is strictly decreasing, and then from 1 to 2. 1 to 2 or 3, 1 to 3, I think 3, and 3 to infinity, it is strictly increasing. Okay, I have few more questions to do. I think it's very lengthy. We'll continue more problems in increasing and decreasing function in the next class. I hope you understood the introduction, and I gave you some example of we solved around 4 problems. We'll do more problems in the next class. Kindly subscribe to my channel and click the bell icon. I hope these videos are useful to you. See you again in the next class. Bye bye.